Quite often, we want to apply a mapping or conversion across the entire context for every property of a particular type. You can apply configurations and conversions in bulk instead of doing that one property at a time. dbContext has a virtual method similar to on model creating called configure conventions. This feature is referred to as pre-convention configuration. So rather than overriding conventions, you're in fact adding your own conventions. Before I start adding these configurations, I do want to point out something about these virtual methods in dbContext. Configure conventions, on model creating, and on configuring. When you use Visual Studio shortcuts to add these virtual methods, they always have the base call inside the method. But you may have noticed that you haven't seen that in any of the code samples that I've shown. These methods are referred to as no-op or no operation. If you look at the code in the EFCores repository, you'll see that configure conventions and on model creating and on configuring are all empty methods. So these base calls that get added to your code do nothing. There are reasons that they stuff that line in there, but that's getting out of scope. But that's why you never see them in my code and why I'm about to delete this one. The configure conventions method provides a configuration builder object from which you drill into its properties, and those properties refer to any and all properties in the data model. And it's generic, so next you specify what types the mapping should focus on. For example, all strings. And from there, you have access to pluralized versions of the property mapping methods. For example, instead of has column type, here we have column type. And these methods take the same parameters as their singular counterparts. So if I want to have all of my strings stored by default as varchar 100 instead of SQL Server's default of nvarchar max, I can define that here as configuration builder properties of type string have column type varchar 100. Additionally, there's a bulk version of has conversion, and that's called have conversion. With that, if I have multiple classes that use the book genre enum and I want that to always be stored as a string, I can use have conversion to do that instead of adding a mapping for every one of those properties. However, if you've created a custom conversion, the shortcut I showed you before won't work with bulk conversions. The reason for that has to do with an advanced feature for pre-building the model that I'm not covering in this course. So if you want a custom conversion that applies to many properties, you'll have to create an explicit value converter class and pass that into the have conversion property. You can see more about how to do this not only in the EFCore docs, but in my Code Magazine article called EFCore 6 Working on the Bucket List, which I'll link to at the end of this module. There's one more mapping I want you to be aware of, although I will only address it very lightly, which is EFCore's ability to map complex types and, by extension, value objects. However, keep in mind that how you achieve this is very likely to change when EFCore 7 comes out, but this is how we do it now. First, I should make sure you understand what I mean by a complex type. So far, every property we've used in our classes was either a scalar type, like a string or a date or an integer, or a pointer to a related entity. But sometimes you want to create and store your own types that are more than a scalar type, but you don't need them to be their own full entity with a key and the overhead of relationships. Consider, for example, the names of the author and artist. Already we have first name and last name in both classes. What if we also want to make sure it's easy to get the full name? So I've added a full name property to both classes. Each of these, by the way, is using an expression body to return that combined name. As I think of more and more great things I might want to do with name, then I have to return to every class in my model that has a first and last name and keep adding these new properties and methods. So rather than having to do that, we can combine all of them into their own type. Here's the example, person name. Note that this type does not contain a key. Since it's going to be used as a property of other entities, it's those entities' keys that will drive persistence. Person name would never be stored and retrieved on its own. It's simply a property of author and artist. And I can easily add more logic to that, like this reverse property, without having to add that to every class that has a name. EF Core is not going to understand this by default, though. It will assume that person name is an entity in a relationship with author and a relationship with artist, and it'll throw an exception complaining that person name needs a key property. To correct this, we need to add configurations in the pub context, and the terminology for this mapping is about ownership. Using the owns1 method, we can express that an author owns its name property, and an artist owns its name property. By default, the way that EF Core persists this is that the properties of the complex type, in other words, the first and last name, become their own columns within the table of the type that owns them. The full and reverse properties don't get mapped because they're read-only. I don't even have to tell the DB context to ignore those. Many developers rely on concepts from domain-driven design, and a very important concept there is called a value object. A value object is a complex type that has some more attributes. However, this owns1 mapping also allows you to persist value objects with EF Core as well. There is a lot more to learn about this feature, and in fact, there's another way of persisting them with value conversions that's discussed in the EF Core docs. But I wanted to be sure you were aware of it because it's definitely a frequently asked question when developers who are already familiar with application design are first learning EF Core. This module gave you insights into additional mappings and conventions that you should be aware of and that you can follow up on as needed. You should now know enough to be able to take them into consideration as you plan how to persist your application data with EF Core. We looked at how EF Core maps nullable reference types when your project enables NRT support. Then I give you a quick look at data annotations for applying configurations. And I'm more interested in your being able to comprehend them when you're reading code samples or other people's code. However, I'm not keen on using them over the Fluent API. You learned a bit about EF Core's support for persisting enums and using value conversions to help EF Core persist types, sometimes types that you want to persist differently than it wants to, for example, saving enums as strings rather than integers, or even types that don't have a database counterpart, such as my favorite, .NET's ColorStruct. Then you learned about EF Core's support for bulk configurations and conversions. And finally, about the owned entity feature for persisting complex types. Because of the nature of this overview, there are no exercise files that go with this module. The next module is another overview, this time focusing on EF Core's database connectivity, so you can get a high-level understanding of things like how you can switch databases on the fly. As always, here are some links to resources that I mention in this module. I'm Julie Lerman, and thanks again for watching Entity Framework Core 6 Fundamentals. Welcome back to Entity Framework Core 6 Fundamentals. I'm Julie Lerman. This module will focus on some additional capabilities of how EF Core works with database providers and their databases. It will be high level to ensure you're aware of these features so you can plan ahead, although digging into them is something to do in a more advanced course than this one. We'll start with a discussion of the various databases you can interact with thanks to the many available EF Core database providers, whether from Microsoft, third-party vendors, or open-source maintainers in the community. One of the Microsoft-created providers is for Azure Cosmos DB, Microsoft's cloud-based document database. If you're using or interested in using Cosmos, you may have questions about this provider, so I'll provide an overview of key things to be aware of about using EF Core to interact with Cosmos DB. Database transactions are a really important topic, so I'll give you the skinny on EF Core's built-in transaction support and some of the possibilities for taking more granular control over how that works. Then I'll hit a few more FAQs about database connectivity with EF Core, dynamic connection strings, connection and DB context pooling, and how EF Core can help when it's having trouble connecting to a database. So far in this course, I've focused solely on interacting with a SQL Server local DB instance. And I did this using Microsoft's SQL Server provider for Entity Framework Core. and this provider works with any version of SQL Server starting with 2012. Microsoft has 3 other providers that it maintains for EF Core. There's one for SQLite, which can work with any version starting with 3.7. They also designed and maintain the in-memory provider, which you learned about in the testing module. And they even have one for Azure Cosmos DB, which isn't even a relational database. It's Microsoft's cloud NoSQL database. But the provider takes advantage of EF Core's inherent understanding of SQL to interact with Cosmos DB's SQL APIs. I love using this provider, and I will give you a brief overview of it in the next clip. Microsoft does have a lot of varieties of SQL Server, so it's also important to understand that this one SQL Server provider works with all the different SKUs of SQL Server, from the Enterprise, Standard, or Developer editions to the smaller SQL Server Express and Local DB versions that we can use for development, and even with Azure SQL. All you need is the correct connection string, and there's not much more to moving from one SKU to another. But Microsoft isn't the only one creating EF Core providers. There are a ton of third-party providers. Some required paid licenses, and others are open source. Here's a list of the database servers you can connect to with these various providers. And some of these providers are available from multiple vendors. For example, there are other companies that create providers for SQL Server, or you can get an Oracle provider from Oracle, or one built by your option of a few other companies that also build Oracle providers. The EF Core Docs has a list that gets updated of available providers with links to their sources. EF Core does a lot of the work needed to interact with the database, and it uses the least common denominators, for example, data types that are supported across all of the servers. Yet there's still plenty that each provider needs to do, for example, ensuring that the SQL is written in a way that works for that database. So after EF Core has examined information stored in the change tracker, it creates something called an expression tree, which is a collection of all the actions that need to be taken. And that expression tree will be the same no matter what provider it's working with. So then it passes the expression tree to the provider, which reads that and transforms it into the appropriate SQL. Then the provider sends that SQL back to EF Core, which goes ahead and executes it on the database for us. Because EF Core is open source, the information that provider writers need to build them correctly is freely available, and the team wants them to be successful. And they work with provider writers to help ensure this, so you should be able to use them confidently. As a side note, Shai Rojansky, who's been maintaining the provider for PostgreSQL for years, was so knowledgeable, and he is super smart, that Microsoft hired him, and he's now a member of the EF Core team.